Hello. In this video, we're going to be talking about functions and function operations. So just as a reminder, function notation looks like this or this. And a function is just a way of writing an expression. So you might have something that looks like this. And that's a function. And if you have to evaluate a function, like if I asked you for f of 3, that just means that in this expression, we are going to take whatever is in the parentheses and we're going to multiply it by 2 and then add 1 to it. So since 3 is in the parentheses, we're going to multiply it by 2 and then add 1 to it, so that we would get f of 3 equals 7. And function notation is convenient because that actually then gives you an xy coordinate. The x is the 3 and the result of performing the operations is the y. So you'd have the coordinate 3, 7. But you can also take functions and you can do operations on functions. So this video is mostly going to concentrate on adding, subtracting, multiplying, and dividing. But say that you had a function that was f of x equals 2x plus 1, and you have a function, let me write that in a different color. You have a function that's g of x equals, let's go with negative 3x. We can actually perform operations with those two functions. So if I want to add, and I ask to add f of x plus g of x, we can actually just perform that operation by adding those two things. So we would have 2x plus 1. That's sort of its own little entity because that's the f of x. And to that, we're going to add negative 3x because that's its own little entity. And as a result, we're going to get a brand new function, which in this case I'm going to call h of x. And our brand new function will be the combination of these two things. So I'm just going to take this and simplify it all out, combine like terms, and make it look at all neat and pretty. So in this case, when we combine like terms, we get negative x plus 1. So the result of adding the function f of x to the function g of x results in this new function, negative x plus 1. All right, let's look at subtraction. So we're using the same two functions. So we're still going to have f of x, but this time we're going to subtract g of x from it. Oops. And when we do that, again, we just take the f of x to x plus 1. It's like its own little thing. And now we're going to subtract from it the negative 3x. So be careful with the signs there because you have double signs. But again, we just take the first function and subtract from it the second function, and it will create a new function, which we'll call h of x. And in this case, again, we're just going to combine like terms. So we have 2x minus a negative 3x, so that's 2x plus 3x, which gives us 5x plus 1. That would be our new function. So this h of x represents those two original functions subtracted. You can repeat this for multiplication. So we have f of x. Now we're going to multiply times g of x. So we get 2x plus 1. And in this case, we're multiplying by negative 3x. So here, our new function, again, we're still going to name it h of x. And we are going to distribute. So this negative 3x, I'm going to distribute to each of the terms in f of x. So when I do that, I end up getting negative 6x squared minus 3x. So that is the new function. And then finally, let's talk about division. So again, f of x, and we're going to divide by g of x. And here, 2x plus 1, and I'm going to go ahead and I'm going to divide it by negative 3x. Now, in this case, we would simplify any parts of this equation or this expression that we could, but we cannot because the whole numerator has to be divided by negative 3x. So I could separate the numerator into two parts and then divide each of those parts by negative 3x, but that doesn't really make anything simpler. So in this case, our simplified solution is actually just the two parts written as a fraction, like that. So that's how you do function operations. One thing that you might have to do is you might have to find a new function. So that's when we did an operation between functions and we wrote a new function. And then you might actually find a value for that function. So let's look at this example. Say you had f of x equals 2x minus 7, and then you have g of x equals x squared plus 4. I want a new equation where h of x equals f minus g. And I'm just not writing the of x's parts just to save time. And then I want to find h of 5. Okay, so I'll start with f of x, that's 2x minus 7. And then I'm going to subtract from that my g of x, which is x squared plus 4. So be careful with signs here. This would be 2x minus 7 minus x squared minus 4. When I combine everything and put it in standard form, I have x squared, and then I have plus 2x and minus 11. So my new function, h of x, would be negative x squared plus 2x minus 11. Now to complete the second part of my equation, it asks me to find h of 5. So that just means that in my new equation, wherever there is an x, I'm now going to put a 5 instead. So I have h of 5, that means I'm going to have negative 5 squared plus 2 times 5 minus 11. Again, be careful with your order of operations here, because this symbol, this isn't negative x squared, it's x squared, and then the opposite of whatever that solution is. So we're going to do 5 squared, which is 25, and then we make it negative, plus 10, minus 11, and our result is negative 26. So that would be the solution to that example. One more example, if you have a function and you actually then want to evaluate it at another variable. So say we have h of x, we want h of x to be equal to f times g, and then I want to know what h of a squared is. And in this case, f of x equals x squared, and g of x equals negative 3x plus 2. So to find h of x, I'm going to multiply those two expressions. So f of x times negative 3x plus 2, which was g of x, all right? And then I'm just going to multiply that out, so I distribute everywhere. So this becomes negative, this becomes negative 3x cubed plus 2x squared. So that's the new function. Then I want to know what h of a squared is. So to find h of a squared, wherever there was an x before, I'm now going to write what's in this place. So since a squared is there, I'm going to write a squared there, and I'm going to write a squared there, because it's just taking the place of x. So whatever's in the parentheses takes the place of the x. So this is an a squared, this is an a squared, and now I can multiply it all out. So I would have negative 3a to the 6th plus 2 a to the 4th. I just had to remember my exponent rules, and that is the solution, or the value of h of a squared. Cool, thanks.